Above your head right now, thousands of machines are still circling Earth, even after they died. They do not sleep, they do not rust in a junkyard. They keep circling the planet hour after hour while Earth turns beneath them. And every so often, one of these old machines even surprises us by whispering back after decades of silence. So what actually happens to a satellite after its mission ends? The answer is stranger than most people expect. Some abandoned satellites come home in fire, some are pushed into distant parking places, and some become part of a growing cloud of orbital debris, the human-made objects in Earth orbit that no longer serve a useful purpose. NASA uses that definition plainly. If it is made by people still in orbit and no longer useful, it is orbital debris. A satellite usually does not die all at once. It may run low on fuel so it cannot correct its path. Its batteries may weaken. A solar panel may stop producing enough power. A radio link may fail. Or the mission itself may simply become outdated. From the ground, controllers may see the first signs as silence, drifting, or a final command that never gets an answer. That is the quiet part of the story. A satellite can lose its purpose long before it loses its motion. In orbit, speed is what keeps it from falling straight down. So even a dead machine can keep circling Earth for years, decades, or longer, depending on where it is. There are 3 common endings. Ending 1 is the most dramatic: burn up. Satellites in lower orbit still brush against the thin outer edge of the atmosphere. That faint drag slowly steals energy from their orbit. Over time, they sink lower, heat up, break apart, and many pieces burn away as they re-enter. Ending 2 is the graveyard orbit. Some satellites work too high above Earth to fall back quickly. Instead of leaving them in busy operating lanes, mission teams may use the last fuel to move them into a disposal orbit. For geostationary satellites, that often means raising the spacecraft roughly 300 kilometers above the busy operational belt. It is not a cemetery with fences. It is more like moving an old ship out of a shipping channel so newer traffic can pass safely. Ending 3 is the problem case: debris. A dead satellite, an old rocket body, a bolt, a fragment from a breakup, or a piece from a collision can become part of the orbital debris environment. ESA's 2025 Space Environment Report says about 40,000 objects are now tracked by space surveillance networks, and about 11,000 of those are active payloads. The rest are a reminder that space is not empty just because it looks empty. Why does that matter? Because orbit is fast, very fast. At those speeds, even a small fragment can hit with enormous force. A fleck that would be harmless on the ground can become dangerous when it meets a spacecraft moving kilometers every second. The deeper risk is not just one impact. It is what happens after impact. 2 objects cross paths. They collide. A cloud of fragments spreads out. Some fragments cross the paths of other spacecraft. One collision can create more chances for future collisions. That is why space debris is not just a cleanup problem. It is a traffic problem, a design problem, and now, a responsibility problem. Space junk is not invisible. The United States Space Surveillance Network, operated through United States Space Force systems, maintains the main public catalog of tracked objects. NASA studies the risks. ESA reports on the debris environment, and commercial tracking companies are adding new sensors and warning tools. Before a rocket launches, engineers compare the planned path with predicted object positions. If something is expected to pass too close, that part of the launch window can be closed. The rocket usually does not dodge debris in real time. It launches when the path is clear. In 2023, the FCC announced its first space debris enforcement action after EchoStar 7 was retired into a lower disposal orbit than planned. That case matters because it shows the satellite afterlife is no longer just an engineering detail. It is becoming part of how space operators are held accountable. The good news is that this story is not only about danger. The future of satellites may look much more responsible. New spacecraft can be designed to deorbit at the end of life. They can be passivated, which means removing stored energy so they are less likely to break apart. Some may unfold drag sails, using the thin atmosphere to pull themselves down faster. Other ideas are already moving from concept to demonstration. Some missions use magnetic docking. Some have tested nets, harpoons, and drag sails. ESA's ClearSpace 1 is designed around robotic arm capture, while Astroscale's ADRAS-J mission has shown what close inspection can look like by approaching an old Japanese rocket body and imaging it up close. It is a glimpse of a future where abandoned hardware is not simply forgotten. Engineers are also improving tracking and coordination, so operators can predict close approaches and move valuable satellites before trouble arrives. The goal is simple, even if the engineering is hard: Do not leave tomorrow's missions trapped inside yesterday's leftovers. The satellites we abandon today may decide how safe space is tomorrow. The next chapter of space exploration will not only depend on what we launch, it will depend on what we take responsibility for after the mission is over. I'm Alan. If this video was helpful, please like, subscribe, and share it with someone who might find it useful. Thanks for watching.